In the last lecture, we were able to successfully achieve objective number 3, which is to objective number 2 rather, which is to get MAC address of the victim and the gateway. And we implemented in the program plan, this corresponds to function to get the MAC address of any given IP address that we supply to the function, and we were able to achieve that. Now in this lecture, we are going to continue scripting. We are going to try to achieve objective number 3, that is spoof the target device that we want to spoof and the gateway. So both spoof the target, go to the target, tell the target that we are the gateway, and go to the gateway, tell the gateway that we are the target device that we want to spoof. So that is what we are going to try to achieve in this particular lecture. So we'll go to the code. So here we are, and then also we created this function get target, but we didn't make use of it. So in this lecture, we are going to try to make use of it instead of hard coding the IP address within the code, instead of hard coding the IP address within the code. So we are going to supply it over the command line. All right, so I'm going to proceed start scripting immediately. So we are going to define a function, spoof victim. So let me call it spoof victim. Okay, so now basically what we are going to do, let me add a comment. So a function to create a PEC ARP response packet. So basically what we are going to do, we are going to exploit the vulnerability in the ARP protocol, because ARP protocol basically devices could get a response to a ARP response even if they have not make any request. So we are going to go to any device and tell the and send an ARP response to that device, even though that device did not make any ARP request. So that way we are going to spoof any device that we want to. We can go to any device and say that we are another device. So and even though that particular device did not make any ARP request, that is a vulnerability in the ARP protocol. So we are going to exploit that vulnerability. So now we are going to create an ARP response packet. So let me call it PEC ARP response. Okay. So and then we're also going to make use of scapy.arp, scapy.arp. Okay, so basically we are creating a ARP packet. So but we are going to also specify some fields within this ARP class, just as we did in line number 34. But we don't know at this moment, we don't know the fields that we are going to set. So for us to know the fields that we are going to set, we are going to print this ARP packet and see the various fields and see how we can go about setting the various fields. And to do so, I'm going to invoke a function show of ARP that is the show function of a packet packet method, or we call it function method, packet method show, to show us the various fields that are contained within this particular fake ARP response packet that we created using the ARP class of module scapy. So pick ARP response dot show. And then I'm also going to invoke all other function method summary and scapy ls function, so as for us to fully comprehend this particular fake ARP response packet. So I'm just printing this to serve as a demarcation between the output. So next I'm going to print fake ARP response dot summary. Okay, so next also let me copy this. I'll copy this and then put it down and then paste it here. And then next I'm going to scapy ls dot ls, and then I'm going to pass that packet to it. Now let's go and run this. Now okay, we need to invoke this particular function, so we're not bothered with this. Scapy arp. All right, so scapy arp. Now let's call this function and see. So spoop victim. So spoop victim, and then okay, so I'll go to the terminal now and then navigate to the directory where I have this desktop. Okay, I'm already on the desktop, sorry. So cd lectures, that is where I'm having those files. Clear the terminal. Now sudo python3 and then arp py, and then I hit enter. All right, now let's see what we are going to have as output. All right, fine. So here we are. We have the output of the three methods we invoke on our packet. Now let's see the first one. So this is a method to show a packet. So basically we see that this is still an ARP request, because by default the ARP class when we create a ARP packet is going to be an ARP request. So but we can change it to ARP response by setting this OP field to 2. So because we can, when we go down here under scapy ls, when we invoke scapy ls, we can see that the value for the OP field by default it is 1, and 1 means ARP request. So for us to change it to ARP response, then we change the value to 2. So we are going to make the OP field value to 2, and then next, since now the source MAC address is going to be from our machine, and then but the IP, since we are going to spoof one of the devices we are going to spoof the Windows 10 machine, so we are going to get the IP address of the Windows 10 machine. IP config, get the IP address of the Windows 10 machine, 10.02.15. We are on the same 10.02, and we're on the same subnet as the Kali Linux machine. So we are going to spoof this particular IP address of this Windows 10 machine, tell the router that we are Windows 10, and then go to the router and then go to the Windows 10 machine, tell the Windows 10 machine that we are the router. So basically the source IP is going to be the IP of the router one time, and then another time we put the IP of the Windows 10 machine. So and by the MAC address, since the packet is emanating from our machine, it will still bear the MAC address of our machine, which is 080027F842A7. All right, so we are basically going to spoof the source IP address of the router and of the gateway, and then change the OP field to 2 instead of 1. And you can see that it is ARP who has 00 says 0.0.2.19. So basically it is by default it is an ARP request packet. So now we are going to modify it and change it to an ARP response packet. So now we are going to we invoke our okay. So on the function definition spoof victim, we are going to define parameters: source IP, IP, and then destination IP. So the source IP is the IP address that we are going to spoof, and then destination IP is the IP address that we are sending that particular packet to. So the source IP, one time it will be the IP address of the source IP address of the gateway, and then another time is going to be IP address of the Windows 10 machine that we are going to spoof. So basically we are spoofing the source IP address, and then destination IP represent the IP address that we are sending that pick ARP response packet to. Okay, so and to send, since we are on a local area network, remember that to send any to communicate, for devices to communicate among themselves in a local area network, they make use of what? They make use of the MAC address. So we need to get the MAC address of the destination machine that we are sending this PEG ARP response packet to. Now this is when our function getMac comes in handy. So we are going to make use of this function getMac. Remember, we run it and it's going to return a MAC address of any IP address that we inputted to it. So we are going to invoke this function getMac and then pass an IP address to it, and then try to resolve that IP address to the corresponding MAC address. So that is what I'm going to do. Now I'm going to enter the destination IP, since that is where the machine that we are sending a packet to. So destination IP, and then okay, so destination MAC rather. So I'm going to define a variable called destination MAC, and then I'm going to invoke this function getMac, and then I'm going to pass destination IP to it, so that we get the IP address of that particular, we get the MAC address of that particular IP of that destination IP. Okay, so now now we have the MAC address of the destination IP. So I'll come to my escape ARP and then set the field. Remember that we say OP is going to be 2, since we are sending an ARP response, not an ARP request. And then now the source IP address is going to be the source address that we are the source IP that we are trying to spoof. So I'll write it as source IP, and then we have the destination. This destination. Okay, and then the destination IP, which is PDST, is going to be the destination IP that we pass as parameter to the function destination IP, and then the destination MAC HWDST field is going to be the destination MAC that we were able to resolve using our function getMac. Okay, so now we have created, and then the source IP is, since the packet is emanating from our machine, the source MAC is going to bear the MAC address of our Cal Linux machine. Well, that is the machine, the Cal Linux machine that we are sending the PEG ARP response packet from. Okay, so let me save this. Now let's go back and run it and see what we are going to have as output. So and then okay, so we need to go and the spoof victim here, where we invoke the function. Now let's set the IP addresses. So let's the source IP let the source IP be the IP of the gateway 10.0.2.1. Okay, and to know your the IP address of your gateway, all you have to do, you are going to come and run a command route-n. So I will just come to the terminal here, and then let me clear the terminal, and then for me to know the IP, I'll just route-n, and then okay, so sudo route-n, and then hit enter. So we can see that the IP address of our gateway is 10.0.2.1. So we are going to make use of that. Go back to the code, and then 10.0.2.1, and then the IP of the machine, the Windows 10 machine, the Windows 10 machine is 10.0.2.15. as we can see it here, 10.0.2.15. So I'll just go over there and import it. So 10.0.2.15. So I'll save it. Now I'll go and run it, the code, and then see what I'm going to have as output. So let me clear the terminal, and then I'll run the code again, run the script, and see what I'm going to get. Fine. Okay, so here we are, and we can see the let's go up and see the output. So we can see that the OP is, instead of who has, it has changed to is at, meaning that it is an ARP response packet. And we can see the source is the MAC address of our Cal Linux machine, but the source IP is claiming to be 10.0.2.1, meaning that the ARP response is from the gateway 10.0.2.1, but it is having our MAC address of the attacking machine, which is the Cal Linux. So basically, we are spoofing the gateway 10.0.2.15, and the destination IP is the 10.0.2.15, which is the IP address of the Windows 10 machine. And then we can see it. We can see the output of the SCAPI of the functions method summary. You can see ARP is at 0008.00 080027 F842A7, which is the MAC address of our Kali Linux machine. Says 10.0.2.1, which is the IP address of the gateway. So basically, we are spoofing the gateway, going to the Windows 10 machine and telling the Windows 10 machine that we are the gateway. And then we can see that, and then now the Windows 10 machine will update its ARP table, and then under 10.0.2.1 it will put our MAC address of the Kali Linux machine. So whenever it wants to communicate with 2.0.2.1, since they are using MAC address for communication on the local area network, instead of sending the packet to the gateway, and then it will send the packet to us. Thereby we are standing in the middle. So, and then next we are going to send that same packet to the gateway as well. Tell the gateway that we are the Windows 10 machine. And to do so, we are going to just invoke this same function again, spoof victim, and then instead of the source being the gateway, the source IP is going to be the Windows 10 machine 10.0.2.15, and then the destination, we are sending it to the gateway 10.0.2.1. So we save it. Now, since we are clear with this, I'm going to delete this. So the printing, so we don't need to print it since we are satisfied with the output. We have successfully created a ARP response packet. So let me delete it. Now we have created the packet, but actually we didn't send it, because when we go and check the ARP table of the Windows 10 machine by entering the command ARP-A, we can see that it is still having the 10.0.2.1 is still having the proper MAC address of the gateway. So we need to send the packet for us to be able to properly spoof the gateway. So I will come here, and then we are going to send the packet. We are going to make use of a function called called send of prom model SCAPI. So SCAPI is send, and basically what this function is going to do, it is going to send the packet and will not get any response for us. Unlike function SRP that will send a packet and then get the response and then return the response to us, which we assign to variable answered list. So basically what this function is going to do is going to simply send the packet and forget about it. So we are going to do so, and then to send this pick ARP response, I will just enter it here, pick ARP response, and then I will save it. Now let's go to the terminal and run this script again and see what we are going to have. So let me clear the terminal and then run it and see. Okay, so successfully we can see that we have been able to send the packet. Okay, so we are still printing something, so I will need to go and check that and get rid of that. Okay, so we have successfully sent the packet. Now let's check the ARP table of the Windows 10 machine by ARP-A. So we can see that we have successfully spoofed the gateway. By now the gateway is having the ARP table has updated to the to the MAC address of the Kali Linux machine under the IP address of the gateway. This is the first one is the proper MAC address of the gateway, but now we have successfully spoofed the gateway. Now the ARP table of the Windows machine is having the MAC address of the gateway 10.0.2.1. So our function is running successfully, but we still need to improve the code. We are printing something that we don't need. Okay, so print and set. Okay, no, we don't need to print this. All right. So something is actually wrong. Yes, so it is printing. Okay, so we don't need to print this. We need to return it instead. Return. So return. So we should be returning it, not print it out. So Okay, so we should return it, not actually print it out. Okay, so now our function is running successfully. When we run the array and see, and then examine the output and see what we can still put in order. So let me clear the terminal again, and then let me run it. Okay, perfect. So we can see sent one packet, sent one packet. So we are successfully sent two packets because we invoke the function spoop twice. That is why we are having sent one packet. But even this sent one packet, we don't need it this way. So that means there is we need to improve the code further, and to get rid of that sent one packet message, all we have to do, we come here and then the verbosity field, verbose, we sent it to false. So the verbose parameter, we sent it to we set the value to false. So just as we did in this line 37 where we have verbose false. So let me go and run it and see what we are going to have as the output, whether it has actually gone away. So invoke it, then run the script again. Perfect. So we can see our script has run successfully without any error. Now, but still, when we go back to the Windows 10 machine and run ARPA command, we are still going to have the MAC address of under the gateway IP address as the MAC address of our Kali Linux machine. But what happened is that after a while, the MAC address of the gateway is going to update to the proper MAC address of the gateway. So since we are still carrying out our ARP spoof attack, we have to continuously send the ARP response packet for us to maintain our man in the middle attack position. So we have to continuously send the pick ARP response packet. So to do so, we are going to go back to our code and make sure that that packet is being sent continuously. So to do so, we are going to make use of what we have learned previously. We are going to make use of our while loop. So I'm going to have while true, create an infinite loop. This will, because this condition will remain true forever, it will continuously keep sending this pick ARP response packet. Okay, so I'm doing such characters. Okay, so it will continuously keep sending this pick ARP response packet by invoking this spoop victim function to send the pick ARP response packet. So this will make sure that we have maintained our man in the middle attack position, and we spoof the gateway and spoof the Windows 10 machine. So this will make sure that the ARP table of the Windows 10 machine or of the gateway did not update to the proper MAC address of the respective machines. So now this will ensure that. Okay, so and then when we send it, but this is an infinite loop, so let's run it and see what we are going to have. Let me clear the terminal and then you run it and see. So as you can see, this will create an infinite loop. Okay, so and to stop it from running, we press Ctrl+C. Now to handle this error, we are going to make use of exception handling method in Python using the try except statement. So and then take note of the error message that we have, keyboard interrupt. Now this is the error method that you have, keyboard interrupt. So using this, we are going to make sure that we have next time we run our script again, we don't have this nasty output. So I'll go back to the code again and then try to include the exception handling method. So I'll put this try, now this try statement, and then I'll push it this my while loop is going to be under the try statement. So we can see that our while loop, the whole of our while loop is under the try statement. So now what we are doing here, we are telling the Python to try running this infinite loop. Now, but we know that something is going to happen because as the program is running, the user of the program might decide to stop the program from running by entering Ctrl+C key combination. Now, to interrupt the program. So now when the user interrupts this program, then keyboard interrupt error is going to result. The program will result into keyboard interrupt error. So, and to handle that error, so I'm going to copy this to tell the Python program that there will going to be an keyboard interrupt. So I'll go back to the code and then tell the Python program try except. Now something is going to happen, and what is going to happen is except, and then we are going to accept it as keyboard interrupt. Then is when keyboard interrupt happen, I want the program to do something. What I want it to do is to print out a message, detected Ctrl+C key combination. Okay, and now the program stop, and now the program will stop. So I'll save it. Now let's go and run the program and see whether this error has been handled accordingly. So let me clear the terminal and then run the program and see what we are going to have. So our program is now running. It is sending our PEC ARP response packet. Now when we decide to stop the program by entering Ctrl+C, what happened? We can see that that error has been successfully handled. Detected Ctrl+C key combination, and now the program will stop. So our program has been able to handle that error successfully. We didn't have that nasty output, but still, when we are running the program, you can see when we run it, we are not having any output. So how are we sure that the program is running? So let's go and add some code to print out a message so that we will know that this program is running, not that our computer has freeze or something has happened. So Ctrl+C and then stop the program. So let's go and see how we can handle something like that. Now let's create a counter that will keep track of the packet that we are continuously sending, and then output that as a message to us so that we know that our fake ARP response packet are continuously being transmitted. So to do so, I'm going to create a counter outside this outside this try statement, and then let me call it packet counter or count packet, packet, or count PEC ARP response packet, count PEC ARP response packet. Now I will assign it with the value 0 because at this moment it is having the value 0. We haven't sent any packet yet. Okay, so I'll come down here. Now at this line number 55, we have sent 2 packets. So now I'll update my counter with 2 packets. So I'm going to put count PEC ARP response packet and then plus equals to 2. So this is what you call compound assignment operation. Or augmented assignment operation, because basically this is a short way of saying count ARP response packet equals to count ARP response packet plus 2, because initially, now what this will do is that count ARP response packet will be assigned with the value that the count ARP response packet is having currently, which is 0 plus 2. Now it will now be updated with the value 2. 0 plus 2 is 2. Now it will be updated with the value 2. But we can write it in a short way by saying count ARP response packet plus equals to 2. So plus equals to 2 instead of writing it in the long way. But it will still perform the same thing. So instead of this, I can write it in the short form: count fake ARP response packet plus equals to 2. Now it will be updated with the value 2. Now I can now print out the packet, and then now also it's very important that we don't bother our computer. Now after sending the packet, we can allow the computer to sleep for some 2 seconds before resending the packet again. So we can, okay, but let's print out the message first. Print, so let's have sent, okay, sent, and then follow, I'm going to put a control format string -s packet. Okay, so and then I'm going to put a control format string, and then I'm going to put the count, count pick ARP response packet, but this is not a string, it's going to be an integer, so I'm going to make use of casting to change it into a string, so so that we can have then close this. Okay, so I need to add another bracket. Okay, so what we have here, basically what is what we call format control string. So I'm telling this the Python program that this is just like a placeholder for something, and that something is going to be a string. This is a placeholder for string, format control string. I'm telling the Python program that I'm going to put a string here, and then this string is going to be immediately what we have after this sign, and then whatsoever that is after this sign is going to be replaced here. And then but this count pick ARP response packet, remember, is going to have an integer value. So when we try to concatenate, when we try to add, because even here we even make use of a format control string for a string, and then we are giving it an integer, which is going to result into an arrow. So I need to use casting to change it into a string. So that is what I did, change it into a string, and then it's going to output sent whatsoever value. Now at this value it is 2, so it is sent to packet, sent to packet. Okay, now okay, so sent to pick ARP response packet, sent to pick ARP response packet. Okay, so that is what basically what it's going to do. Now next, what I was saying is that after sending the packet, we want the computer to rest for some 2 seconds so that it will not be like a DDoS attack on the machines that we are sending the packets to. So let the computer rest for some 2 seconds before attempting to send the packet to the gateway and to the Windows 10 Windows machine again. So to do so, we are going to make use of time module. So time.sleep, and then invoke a function called sleep, and then let the computer rest for some 2 seconds before attempting to send the pick ARP response packet again. But we didn't import module time, so I'm going to go up there and import module time. So I'll come here and import module time. So come here, import time. Okay, so I'll save it, and now let's go up and run it and see whether we'll be able to achieve what we were trying to achieve. So run the code again and then see what we are going to have as output. Okay, so we can see that the program is sending the send to pick ARP response packet, send 6 pick ARP response packet, send 8 ARP response packet. Okay, so we are going to stop here, and then in the next program we are going to see how we can improve the code further and try to improve the code, and then see how we can make the program better. So I'll stop the program by entering Ctrl+C, and then we can see that detected C key combination, and now program will stop. So in the next lecture we are going to make the program look more nicer.